Welcome everybody to today's Midwest Cover Crops Council webinar called Making Weather Informed Decisions. I'm Ethan Teese. I'm the Conservation Field Specialist with Iowa State Extension and spend half my time working with the Midwest Cover Crops Council as well. Today's webinar is going to be in two parts. So I'm going to start us off talking about the Midwest Cover Crops Council, just to give everybody a brief introduction, and then a little bit about how we use climate data in some of our tools. And then I'm going to pass it off to Austin Pearson of the Midwest Regional Climate Center, not to be confused with the Midwest Cover Crops Council. We have very similar acronyms in MCCC and MRCC. So starting off, we'll talk a little bit about what Midwest Cover Crops Council is, in case anybody on the webinar is unfamiliar with Midwest Cover Crops Council. So the mission of Midwest Cover Crops Council is to facilitate widespread adoption of cover crops across the Midwest. And we focus on those first steps of integrating cover crops into row crop rotations. So trying to provide information to those new to cover crops so they have a successful starting point. So our region goes from the eastern side over in Ohio and Ontario to the west to Kansas into Manitoba and Canada. And our southern range is the bottom tip of Missouri there, up north into Manitoba and Ontario and Canada. So what does Midwest Cover Crops Council provide in tools for those looking to get started in cover crops? One of our things we provide to producers starting out is cover crop recipes that are specific to each state or province. So those recipes are tailored to the common crop rotations in those states and provide recommendations of cover crop species and management techniques for those crop rotations. We also have developed a selector tool that lets producers explore seeding dates and species traits specific to the county in their state. So they can see seeding dates specific to their county's weather data, which we'll go further into later here. We also produced the Cover Crops Field Guide. Oh, my background's going to blur it out, but it's a handy pocket-sized field guide with basic cover crop management information general to the whole Midwest that you can keep in your truck or tractor for on-the-go cover crop questions. We also are continually updating our Midwest Cover Crops Council website. On there, you'll find Midwest Cover Crops Council events, like our annual conference and these webinars. And then we have specific topic info on cover crop related subjects. So we have pages for termination, equipment, planting, and other pages as well that has specific information on those topics and links to other articles. And then we do provide trainings, so virtual trainings and webinars like this webinar you're on today, and some in-person training opportunities as well in the states we cover. So today we're talking about weather-specific information, and the place Midwest Cover Crops Council uses weather data is in our Cover Crop Selector tool. So the selector decision tool is designed to be a learning tool for producers to help them select a cover crop species that meets their goal and provide them with seeding dates specific to their county. So in the tool, you can find those seeding dates that are supported by 30 years of county-specific climate data. You'll see different cover cropping goals. You're able to select multiple goals so you can determine the best cover crop species to meet your goals, and soil type and drainage classifications as well. When you're in the tool, you can click on all those species to find out more in their info sheets with information specific to your state, and the tool is mobile friendly as well. So for those unfamiliar with the tool, when you go into the tool, you select your state or province, and then you select your county, and we're able to provide you county-specific weather data to calculate seeding dates specific to your county there. So when you pull up the tool to see your seeding dates specific to your county, this is what it's going to look like. So you can see on the left there, we have the species listed out, and then they have a numerical rating based on the goal you put in with 4 being excellent and 0 being poor, and it's going to rank those species based on that goal or multiple goals you put in. And then it's going to show these bars of the green bar being where we predict in your county you'll have reliable establishment year to year for that cover crop species for seeding dates. And then the yellow bars are either a risk to freezing that cover crop before it gets started or possible moisture risk to establishment. And you can hover over those bars to see the specific seeding dates when you're in the tool. So how do we use frost data to determine these seeding dates for your county? So we use 30 years of frost data across these state and provinces. And then when we update the tool, experts in your state, university experts, NRCS, farmers, and seed dealers will work together to work on a set of seeding dates for a reference county in your state. And then other counties in your state can be calculated off the frost data for your state in an algorithm to determine the seeding dates across your state so we don't have to set them for every county. The data we use to set those dates is the 28-degree temperature probabilities. So we look at the 10%, 50%, and 90% probability of the last 28-degree temperatures in the spring, and the 10, 50, and 90% probability of the first 28-degree temperatures in the fall. So we utilize data from many weather stations across our whole Midwest region and ones outside of our region, so we don't have drastic drop-offs on the edge there. And using ArcGIS, we can take in that weather-specific data for each of those stations and then develop a heat map of that data so we can see how it varies across these weather stations, and then use the average of that heat map specific to each of these counties to develop those averages for our counties. So you can see here for one of those 28-degree fall data sets that we've determined here in ArcGIS, and all the different weather stations we've pulled data from using their 30-year averages for those 10, 50, and 90% probabilities. So I just pulled up 2 versions of the tool the other day just to show how those dates change. From Iowa, we use Story County as our reference county, and then Lyon County, which is in the far northwest corner of Iowa. You can see by setting our dates in Story County, Iowa, that our algorithm using those 28-degree probabilities has changed some of those seeding dates based on the dates we've set for Story County. So you can see our dates in the spring are a little bit later, and our dates in the fall are a little bit earlier, just based on that being further northwest than Story County. We have a little bit later dates being cooler in the spring and earlier dates being cooler in the fall. So our algorithm is able to change those seeding dates just based on this data. And be sure just to stay connected with us to find out about more webinars, our conference, and updates we do to the website. You can join our listserv where we send out regular emails of events coming up. And you can follow us on all our social media pages, YouTube, Facebook, and X. All of those are at Cover Crops MCCC. And then bookmark our website as well. And that's all I have for you. I'm going to pass it off to Austin Pearson of the Midwest Regional Climate Center. Again, not to be confused with our very similar acronym of Midwest Cover Crops Council.
Thank you, Ethan. So my name is Austin Pearson. I'm a climatologist with the Midwestern Regional Climate Center. We're located here at Purdue University's campus in the Department of Agronomy. Right next door to Dr. Lee Schweitzer's office, if you all are familiar with Purdue's campus. I will, however, be talking a bit more about some of the different tools that we have available on our website. And so one of the tools in particular will be the freeze date tool. And a lot of information that Ethan covered, looking at the freeze date tool on or the cover crop selector on their website. Um, we'll talk a little bit more about freeze dates on our end and the different products that we have available for you all to assess those freeze dates for cover crop establishment, termination, all those different things to consider for that. But first, I am with the Midwestern Regional Climate Center. Again, we cover states from Minnesota down to Kentucky, over to Missouri, up to Michigan. And so it's a 9-state region that we provide data for, climate data, tools, and interactive maps to help customize services for Midwest and people across the nation. And so even though we cover that 9-state region, we can easily see with the freeze date tool that I'll be showing you that we cover a pretty large area with that tool with the north central US and looking at freeze and frost dates for that. So I did want to talk a bit about impact of freezing conditions on cover crops before I did jump into the tools. And so it's very important, as Ethan was showing, that it's very species dependent. So understanding how the species tolerate different freeze events. Also, some will tolerate different temperature thresholds. And so a lot of temperatures for a killing freeze in ag, we look at the 28-degree freeze threshold, and we would call that a hard freeze. Now, there are other cover crops that or different species that would be more hardy to that. And so, you'd have hardy species like the cereal rye that can tolerate multiple freeze events. You have to terminate those in the springtime before the growing season, or less hardy species that do terminate due to cold conditions, like your oats and radish, that will winter kill oftentimes after that first hard freeze. And so there's a lot of different things to consider when looking at those. Also, when you're looking at growth stages of the cover crops, young or poorly established cover crops are more vulnerable to those freeze damage events. So you'd have to pay attention to those when you're assessing your stands. And then, so if you have well-rooted stands, they oftentimes withstand the cold stress and the just massive temperature swings that we can see in the fall and also the springtime. Soil moisture also plays a big role in that. So dry soils increase the freeze stress on the roots. So that moisture that's in the soil actually increases. It can increase the risk of plant mortality and compaction damage as a result if you're driving across the soil or anything like that. And then if you graze that, you can also increase compaction issues on that. Functional impacts also, freeze damage can reduce the biomass, the ground cover, and the nutrient uptake. And so you could also, if you're eliminating that biomass that's on the surface, you may be more susceptible to both wind erosion and water erosion. And so I remember a couple of years ago in December of 2022, it was a really cold winter, and really cold right after Christmas, very windy. We had a little bit of snow, but once the snow had blown, you could see the tops of the soil of the snow, and it was almost like black as a result of the amount of soil that was lost from the winds. And so, winter kill may be desirable for spring management, but it does reduce that erosion protection that happens over the winter time. So it's another trade-off when you're looking at that. Early fall freezes can also limit the fall growth and establishment. So one of those things that you can see with that. Late spring freezes can damage overwintered crops during regrowth. And so having proper soil moisture also in the fall is really important, because as you saw, many areas across the Midwest were dry this fall. And so cover crop establishment was a bit harder because the lack of moisture to cause the crops to germinate. So stands may not look as great this year as a result of that. And every year is different. We always have all kinds of different assessments and things when we are considering our cover crop establishments each year. And so when we look at our freeze date tool, you can see we've got the north central part of the United States here in the tool. And so how does this support assessments of cover crop establishments, past events, historical context of our first and last freeze events, whether a freeze is late or early compared to normal when we look at that whole period. And so it really allows us to look at the current season and determine how that fits in perspective to the long-term data. And so with this tool, we do have data available from 1950, I believe. And so we have that information that you can look at. You can identify typical windows for fall and freeze, spring occurrence. You can also access or assess the likelihood of early and late freezes impacting cover crops. You can also look at how the spatial variability and timing of freezes changes. So obviously, if you're up in Minnesota, the northern part of Minnesota, or the upper peninsula of Michigan, you're obviously going to be dealing with freeze a lot later in the season than what you would down in southern Indiana. And so a lot of different things to consider with that. Also, decision support, you can inform cover crop species selection, which it's nice to see that the cover crops tool has that built in already. But there's other sources that you can look at and figure out that information for that. And then support planning for termination, grazing, and overwintering strategies of cover crops. And then also understand and track shifts in freeze dates over time. Is our typical last spring freeze getting earlier or later in the year? Well, that depends on your location. We'll dive into that here when we look at this tool. And then also, understanding how changing growing seasons and managing adaptation, shifting planting dates, using different species, different varieties of those species. A lot of different things to consider when you're looking at things in a climatological perspective. So when you look at the freeze tool, one of the things that you'll notice is that we've got grids, and each county has data. One of the things that's important to note is that we are pulling gridded data for these assessments. And so we're not actually pulling station data. We are taking interpolated style data that is pushed into grids, and then we could get county values for your product. So one of the things that's important to note is that that's very useful when we're trying to fill in spatial gaps between weather stations, because not every county has a weather station that we can rely on data from. And so we can interpolate between those two and produce a grid to give us ballpark freeze dates. And so the data that you'll see on this map are not the exact freeze date for those specific counties, but a ballpark from when you would specifically see those. And we'll talk a bit later here about different tools that are available for you to go and get the exact station level data on our website and get your freeze probabilities, your first and last freeze and snow events if you want to look at those. So there's a lot of different resources on our website that you can grab that information from. But first, let's go ahead and stop and talk about the freeze date tool. And so again, we've got gridded data from 1950 to 2025. So if you look at the tool, you'll be able to see the last spring freeze events for 2025. And then we'll populate the fall here probably at the first of the year or shortly after. But we can look at the first fall freeze, last spring freeze. We can also look at growing season lengths and how that has changed over time since 1950. And so a few definitions before we jump into the tool. We look at the earliest. And so this is the earliest date on record in which the freezing temperature threshold was reached. So the earliest day in the year when we had our first fall freeze or last spring freeze. Conversely, you look at the latest date on record when the freezing temperature threshold was reached, be the last time or the latest time of the year we've seen that. The average would just be the mean of all freeze dates on record. The late would be the 90th percentile, meaning that there's only 10% of all freeze dates on record that occurred after that. And so that's something you can see with that. And then the earliest 10th percentile, so early 10th percentile of freeze dates on record. So only 10% less or earlier than what that occurred. And so I mentioned earlier too that not every species is susceptible at 28 degrees Fahrenheit. So we have these customized freeze thresholds ranging from 20 degrees Fahrenheit to 40 degrees Fahrenheit within the tool. And you can see how that changes over time. So we can also move between regional maps and local charts and get scatter plots of all the freeze events and looking at the trends based on those. And so those are different things that you can assess with this tool. When you jump into the freeze date tool, you can get this menu structure that's up at the top. So you have your first fall freeze, last spring freeze date maps, growing season length, first fall freeze trend maps, last spring freeze trend map, and growing season trends. So your trends are going to be focused on the bottom, and then the actual freeze dates you can and the growing season length on the top. And so here we've got a map of the first fall 32-degree freeze dates that's displayed. You look at this, we have the scale adjusted to the earliest first fall freeze and the latest first fall freeze, just depending on the location across the north central US. You can also go in here and adjust your freeze temperature threshold. So you see freeze temperature, you can adjust that down to 28, down to 20, 22. There's all kinds of different temperature thresholds that you can get. And then you can also select your statistic. So your average, so you're looking at the average freeze date. You can switch it to the earliest that's ever recorded for each location, the latest, average, late, and early. The tool does default to the average statistic. So I wanted to make sure that we pointed that out. If you like what the tool is showing, you can also download the image and look at that information you can put it in presentations or any other reports that you have to do with that. So I wanted to pull up an example of the last spring freeze date map in Indiana. And so here on this particular map, you can see for Allen County, we have the average statistic for 28-degree freeze. In Allen County, 28-degree freeze date, April 12th. And you can also go around and mouse over all the other counties and see what the average last spring freeze of 28 degree was in this particular tool. And so keep in mind that you'll have labels, all that information to see on the tool, and you click over and you see that specific county and go from there. I have the earliest fall 28-degree freeze data here pulled up for Columbia County, Wisconsin. And so here you go through, you select your 28-degree freeze temperature on that. You look at the earliest statistic. And so the earliest fall freeze of 28 degrees Fahrenheit is September 23rd in this particular product. So you can see there. And then if you look up in the north central portion of Wisconsin, you see that dates get earlier than that. So one of those things that you can see with the tool. Also, you can look at the average first fall freeze here. So I wanted to go ahead and show that for Columbia County, Wisconsin. The average first fall 28-degree freeze was October 17th. So you can see that with the climatology with that. And then we have the earliest first fall 28-degree freeze, September 23rd. Again, you can see that on the statistic. If you want to look at the last spring freeze date map, if you wanted to go mouse over again, this is the latest last spring 32-degree freeze for Webster County, Iowa. And so latest last spring 32-degree freeze, May 24th for that particular county. Again, just kind of showing you some different iterations that you can try with the tool and hopping around, seeing those. You see some areas that are more extreme than others. And so those are things that you can play with the map. I wanted to also plot the growing season length map. And so these are essentially the number of days between the last spring freeze and the first fall freeze, depending upon the threshold that you select. So I wanted to plot the 32-degree growing season length. And so again, we're looking at the last spring freeze of 32 degrees on average and the first average fall freeze. And so here for Scotland County, Missouri, you can see a growing season length of 178 days. And so you can use that to look at different, crop varieties. You can use that to look at if you're vegetable gardening and making sure you have enough days to get the seed planted and growing based on that allotment of time that we have with that. So you can see this within this specific part of the tool. Now, really where I get the most value out of this tool for me to understand as a climatologist how our freeze seasons and frost seasons are changing over time. is really kind of cool. And so here we have the first fall freeze trend map. And so we wanted to look at the decadal change in the freeze events. And so here we're looking at the trend in the first fall last spring freeze. And for this is for Portage County, and it's actually 3.5 days later per decade based on that trend. And so you can select different temperature thresholds as we have specified in the other last spring freeze date maps, everything you can select the temperature threshold. The other nice thing with this, you can also filter out whether the trend is actually statistically significant. And so if you do that, you can click on that and click yes. Once you start doing that, you can actually see that the trends for mostly significantly most significant that are happening are actually getting later in the year. And so here we are later in the year based on that per decade. So first I want to go back and show you that there is some variability when you're looking at different locations. So you can see that there are some locations that are sprinkled in, you can see are getting earlier per decade. The thing that to note is that based on our statistical analysis and behind the scenes in the tool, those get filtered out. And so you can see there are several counties across the north central U.S. where we are seeing this change, where that first fall freeze is actually getting 3.6 days later per decade based on the tool and what we're seeing within the data. Now, if you click on the tool, you notice back up here on this graphic, you can click on a county to see more data for that location. And so what this does is that you get a plot with all the freeze temperatures of freeze thresholds, so 20, 25, 28, 30, 32, 35, 36, 40. You can see all those different thresholds, and you see all these plots together, and you're like, this is confusing. There's a lot of data on here. You can actually check off all the different thresholds that you don't want to look at and see the time series and look at how that is changing over time. And so, for instance, you can do this for freezes by decade, growing season, all those different tools that are up here at the top menu bar. You can also adjust the time period for data that you want to see. So you can actually trim data out if you don't care what happened in 1950. You can restrict it to 2000 to 2025 only if you would like to do that. But here again, we're looking at trend and last spring freeze dates and information right here. And so I clicked off different temperature thresholds, and I wanted to look at our freeze thresholds for 25 degrees and 28 for last spring freeze. And so we've got each year the last spring freeze for every calendar year since 1950 plotted on a map, and we've got a time series or a trend line that's plotted showing how that's changing. And so here, based on this, the last spring freeze with May that's happening over here, we can see with this particular tool that the last spring freeze is actually getting earlier in the year with this product. And then the same thing can be seen for the 28-degree freeze. Now, it's important to note that you can see the different freeze thresholds, they're all changing differently. And so you can see that you can look at the different freeze thresholds and make determinations based off of that. Again, you can also look at the box and whisker plots. So if you're looking, you can get the upper whisker for this particular box. You can click on it, hover over it, and it'll provide all that information for that. And what this is showing is that we've got a pretty significant change for Portage County, Wisconsin, where back in the 1950s, the earliest events happened in early September. The latest events here on this mid-September. If you look at the data now for the earliest or the most recent decade with the 2010s, we've pretty much shifted quite a few weeks based on this particular tool from that. And so you're looking at the latest freeze events for that decade being just shy of the last of October. and the earliest occurring in that first week of October. So quite a significant change in what the data are showing from the 1950s to the 2010s. Wanted to also show you the trends in the growing seasons. So here you can see we have the average start date of May 9th for the freeze event. You can also see that this is for the 32-degree threshold. You can do this for all the others. And then the average end date for those. And so the tails, you can see trend lines plotted with that. And so it's getting wider on trends. So on average, it's getting wider. So what does that mean to the growing season? Well, we're seeing a lengthening of time between the periods in which we see our last spring freeze and first fall freeze, indicating the growing season length is increasing at that particular location. Now, that doesn't automatically mean that the fields are conducive for work, right? You have moisture to contend with, a lot of different things to play with when you're making those decisions. If you're interested, you can also get tabular data. And so one of the nice things with this is that you can look at the freeze thresholds. If you're not a more graphical person, when you're looking at data, you can look at the actual events for each of those. You can look at each season's first freeze date and last freeze date for each freezing threshold or temperature threshold. You can also look at the length of days and figure that information out from the specific tool. And then you can also look at the frost freeze climatologies. For each threshold, just a summary looking at the earliest first fall freeze for a location and the last first fall freeze for that location. You can get that for all the statistics that are within the tool. So just another way to look at the different data that are available within the product. Now, we've talked briefly about the gridded data that are available. I wanted to also point out where you can actually go and grab station data. And so if you've ever been to the Midwestern Regional Climate Center website, you go there and we've got 3 predominant tools that are featured on our main website. And then we've got seasonal products and other cool products that we release throughout the year that are available on the main page. When you look at this, we've got Climate here on this. It's a online data portal. And so if you go there, you click on it, you can go in and you can go and grab weather data for specific locations. Any location that has data in the United States, you can go and grab those types of weather data, mainly from National Weather Service co-op stations. And so manual observers going out and recording those data. If you look at hourly data, you can go and grab airport data from those, where they're pulling the hourly data each hour, obviously, from the airports, and you can grab that. But today we're going to focus on the daily data section. And so once you click on the daily, it's going to open a menu page where you go and select your product category. This is automatically going to default to daily single station once you go in and select that. The main thing that you'll have to do is go and select your station name. And so you can select it based on a map. You can go select, if you know a co-op station that's nearby that you want to look at, you can select that. You can type it in by city location, grab the data from and select the station based on that. Once you have it selected, it'll set your station name to the station that you selected. And then you can go down and select your product from this. So if you're wanting to just get simple daily data between 2 dates, you can grab your temperature, precipitation data for every day based on the period that you specify. And once you select all these inputs and the variables, you can hit get results. Today, we're just going to focus on the freeze probability data and seasonal first and last data in the tool. But there's so much more in this. You can get lost in it. And you can get growing degree days, look at the accumulation of heat units over the growing season. Just a lot of different things that you can do with that. But the first product I wanted to show you, if you go to the selected product section, it's called the first and last freeze and snow. And so what I've done with this tool is I wanted to plot the last 10 years of data where we're looking at the calendar year where we get the first spring and last fall freeze for each particular station. You can go in or for the station that you've selected. You can go in and specify your freeze threshold temperature. And if you're curious, you can also accumulate the precipitation or any of those events between the first and last events that's specified during that freeze period. And so here with this tool, I went ahead and plotted the West Lafayette 6 Northwest station, which is out at the Purdue Agronomy Farm here northwest side of the Tippecanoe County in Indiana. I've plotted the last 10 years of spring freeze, the first spring freeze and last fall freeze based on 28 degrees Fahrenheit. And so here we've got the years. We even have the current year as it's concluded. We've already had our first fall freeze, and winter has just been pretty scary here so far for the first part of the year. But we do have warmer temperatures on the way for folks, so don't get too used to the cold. But when you're looking at the last spring freeze, you can see all the dates that are listed here. For 2025, we saw a last spring freeze temperature of 28 degrees Fahrenheit on April 13th. And then we saw our first 28-degree freeze on October 24th. And we've also got the frost season length. So this would be your growing season length based on those two temperature thresholds. And that was at 195 days. You can see the whole range of data. We've got the earliest or minimum for that particular period. So the earliest that ever happens for that 10-year period was on March 24th, 2017. For the last spring freeze, the latest was, or the earliest first fall freeze was October 8th, 2022, with the frost-free season, the earliest being 161. So that looks at from that. You can also see the median, and you can see the latest for each season. Pretty cool tool, in my opinion. But I'm also a weather geek and nerd when we're looking at this data. I also wanted to show another cool tool where we have the freeze probability for the specific station. So I wanted to, if you clicked on that, select a product and navigated down to freeze probability, I pulled data for West Lafayette 6 Northwest for the past 30 years. We do require a minimum of 30 years to be selected for this. So we're computing the probabilities and occurrences of when the freeze events occurred over that whole 30-year period. And so what I'm looking at here is that we get a probability graph that pretty similar to what Ethan showed earlier with their tool. But we've got the 10%, 20%, 30%, 40, 50, 60, 70, 80, 90, and latest for each temperature threshold. And so if you're not, understanding, so the earliest on the map or the earliest freeze event for a 36 degrees for West Lafayette 6 Northwest was September 19th, which is pretty early in the year. You can get frost events at 36 degrees versus the latest event for that first 36 degrees Fahrenheit was October 26th. If you go down here and you start looking at the 28-degree threshold, you can look at September 23rd versus November 12th for that particular event. But the nice thing is that you can also look at this graphically. And so here we've got the 36-degree line. Here we have the 20-degree line. And so we're looking here, what this is basically saying is on September 22nd, the probability of having a 36-degree Fahrenheit freeze on September 22nd is pretty low, about 10%. Versus when you look at October 14th, there is a really high percent chance that you would have that freeze event at 36 degrees Fahrenheit. Conversely, you look at the 28-degree line, the green line, we have a 10% chance of freeze occurring before October 5th on that graph. And then looking at November 8th, more than 90% chance. So things that you can see with those lines. And so another tool that you can see with that there. I did want to quickly talk a bit about current conditions and forecasts versus climatologies. Climatologies show what is typical for a region. So everything that we've discussed up until this point has been climatology based. Okay, it's great for understanding the risk and context, but not really today's reality. So that's where you have to really start making your decisions in real time and paying attention to forecasts for looking at short, medium, and long range forecasts to anticipate the weather. And then that also allows you to proactively adjust your decisions instead of reacting to events that happen right away. And just another note is that climatology supports planning, not the operations. And so best used to set expectations and assess long-term risk. The current data and forecast drive day-to-day and week-to-week management. And so how do you do that? You've got to stay on top of current conditions. And so stay on top of current conditions, looking at forecasts. I worked with the United Soybean Board this last year at developing an ag climate dashboard. And so we have that available on our website where you can gather data from recent conditions. You can look at daily and weekly climate summaries, interactive maps where you can see precipitation totals over the last 7 days. You can also look at 30, 60, 90 different departures from normal over those days. You can look at drought assessment. You can look at extreme weather information, notable events, all those different things available within that ag climate dashboard if you go to our website. We've also got forecasts. So we pulled in the National Weather Service forecasts. If you go in, you can allow your location services on the device that you're looking at. You can do it on your phone. You can do it on your web browser, and it'll automatically pull your location. If you don't like the location it pulled, you can type in the location and get your forecast. We've also got Climate Prediction Center short and long-term maps. We've got seasonal outlooks available within this. We've got our climatology. So we talked about the freeze date tool. We've got a soil climatology tool that's also available. You can look at soil temperatures where they cross over 50 degrees and other thresholds for that particular tool. We've also got products and tools available for growing degree day assessment, whether or not to scout for water hemp, not palmer, but giant ragweed. And all those are based on growing degree day thresholds, but also incorporates forecasts to look at whether or not there's going to be peak emergence or early onset of emergence of certain weed types. And then we've also got availability of state resources. So if you have weather networks in your state that are university owned and operated, calibrated state climate office websites, all those are available for those various state resources. And so I just wanted to provide a few screenshots of what you would see within the dashboard. So for recent conditions, you get your maximum and minimum temperatures for the last 7-day period. You also get your precipitation, and you can mouse over and get those for that particular period. You can also look at current season freeze maps. So if you wanted to look at how that changes spatially over time, you can get when the last 28-degree freeze happens. You can also get the last 32-degree freeze, or you can get the first 28-degree freeze, or the first 32-degree freeze based on mapped products on that. If you're also curious, we've got another freeze tool that you can access from the dashboard. You can look at the most recent dates of 28-degree freezes. You can look at the lowest minimum temperature over that period. So I plotted the lowest minimum temperature from July 1st to December 15th. So we had a really cold spell here recently. And you can see that the lowest minimum temperature for most folks in Indiana was -5 to -10 degrees Fahrenheit. Conversely, if you look up in northern Minnesota, they've had temperatures as cold as -22. That doesn't sound fun to me. I don't know about you, but different things that you can see from the tools. And we've also get different freeze climatologies based on these products. We also have soil temperature maps. You can look at those, get the soil temperature under sod, under bare soil. These are from the university-owned weather stations called Mesonettes. So you can grab data from those different products. You can also get soil moisture and look at how the soil moisture is across the region. And I know right now we're dealing with a drought in the state of Indiana, and many of our soils are less than 5th percentile for soil moisture at this current time. And so a lot of different things to look at that. We've also got maps of growing degree days and how they compare to normal. And so you can look at those on the dashboard. And we've also got the US Drought Monitor. So you can see the most recent drought monitor. We've got several areas across the Midwest dealing with drought, also impacts seed establishment, germination, all those different things when you're looking at these particular products. And then we've also got maps for corn areas in drought, soybean areas in drought as a result of this being an ag climate dashboard. Well, if you look at the forecasts, I went ahead and pulled up the forecast. This was back in August, seeing a sunny 71-degree day forecast for that particular time period looked fantastic, right? But obviously, we're not dealing with that at this point in time. But you can get the most recent forecast for the day and also the next 7 to 10 day period from the National Weather Service right in this dashboard. We've also got the Climate Prediction Center outlooks that are available. You can look at the elevated chances for above normal temperatures that are happening mid-month here in December. And so you can see that. You can also see that we've got near normal chances for precipitation December 20th to 24th, and below normal chances for below normal precipitation in Nebraska, Kansas, Iowa, all those different things. With this, we've got the 6 to 10 day, 8 to 14 day, monthly, and seasonal outlooks. And so you can see the winter outlook for December, January, February, colder conditions up north, warmer, equal chances, temperatures for above or below normal here in central. And you can also see above normal chances for above normal precipitation in that dashboard. And those are from the Climate Prediction Center. And then a lot of the forecasts that the Climate Prediction Center produce are based on the ENSO conditions, so the sea surface temperatures off the southwest coast or the western coast of South America, and how that impacts the jet stream and the overall storm pattern in the US. And if you go to climatologies, there's our friend, the freeze date tool that we talked about here today. There's also the soil temperature climatology, where you can look at the earliest and latest date where you saw soils warming above 50 degrees. We've got different temperature thresholds available in that tool. We've also got the corn growing degree day tool that you can grab from this product. So you put your plant date, you got your freeze and frost risk as a result of that. You based on your hybrid maturity and the growing degree days on the label of the bag, you can determine the typical date that you would get the silking, and also black layer based on that. So a lot of different tools available. We've also got the weed emergence scouting tool. We've got a pest forecasting map. Alfalfa weevil was a big deal this spring in Indiana. And so we had agronomists reaching out to me for tools to figure out how to determine what growth stage those would be at. And so we had those available for you all to grab and worked with agronomists with that. There's a crop disease forecasting tool. So if you're looking at treating tar spot in corn or anything like that, gray leaf spot, anything like that, looking at your return on investments for fungicide applications from that tool. From the Crop Protection Network. And then if you go to state resources, you've also got data available from Mesonet stations. So if you're in the state of Indiana, we've got the Purdue Mesonet, you can see that there. Illinois has the Illinois Climate Network. Wisconsin has WiscoNet. Every one of those pages that you navigate across in this dashboard, you'll be able to get those state-specific resources from that. In Iowa, we've got the Iowa Environmental Mesonet, which they have a plethora of tools available. Very great for users in the ag industry to look at real-time weather conditions and historical conditions, ag tools. That pest tool that I talked about is also there. And so we've also got links to the Iowa State Climatologist. Thrown a lot at you for the ag climate dashboard, but ultimately this is a work in progress, and we're going to continue updating this. So if you have tools that are available that you use, we would love to link those within the dashboard and make sure you have the proper information to make the decisions on your farm. And so if you have time, you can submit a survey on the main webpage, grabbing that information. There's a fact sheet if you want to promote it to people across the region. But this could not have happened without the funding from the United Soybean Board. So in summary, there's a lot of different things to look at when you are making decisions and planting cover crops, planting soybeans, corn, strawberries, tomatoes. Everything is weather dependent and is impacted by freeze events. So we talked a lot about freeze risk today. We've also got other monitoring tools like the Ag Climate Dashboard that you can go and get recent conditions forecast, no matter if it relates to freeze conditions or not. It relates to moisture, temperature accumulations for heat units, all kinds of different data that are available for you, which you are paying for through your tax dollars, as our center is federally funded. But when you're looking at making the best decisions for your farm, is combining all three. So climatologies, your real-time observations, and also your forecasts to look at things. And so with that, that's really what I have today. Wanted to give you my contact information if you wanted to follow up about any of the tools that we talked about today. I've been noticing some questions and people raising hands for questions in the chat, but I am happy to answer those as we go throughout the rest of today.
Yep. Thanks, Austin. I can read you a couple of the questions that came in on the Q&A feature. So somebody asked, can we see state boundaries more clearly and or see major cities when looking at some of that?
That's an excellent question. I mean, that would be something that I would have to take back to our product development team to see if they would be willing to implement that. But I will say that the tool itself, if you hover over the counties, you're going to get the county name that's there. If you look at the state boundaries, they are there. Maybe we could bold those a bit more. But yeah, that's something that we have available within the system. I don't know if we're going to be able to overlay the city names and how selective that would be because we are using an interface that may clutter up the tool a bit. But yeah, I think that's something that I can take back to the product development team to see if they would be at least open to implementing any of those changes. And I see Brian Overstreet, who I've worked with extensively in my extension days and continue doing so throughout my career here at the Midwestern Regional Climate Center. He's asking if you can set the freeze temp at 20 degrees instead of 28. I believe so. Let me go back through the tool here. I think 20 degrees is listed on there. Doing this all on the fly. I'm pretty sure it's on there, Brian. We can look at it. If not, we can probably add it.
And then if you can see that next one there, looks like a potential connection here. So maybe, you know, you and this person can connect outside of the webinar too.
Yeah. So I will note that if anyone ever contacts and wants the data for the North Central region, we can provide. We have provided these data via Excel or CSV format to look at. We did not do the analysis for the southeastern U.S. For this particular reason, but we could probably follow up and provide methodology that we've applied to this particular product and how we access the data. And we're always looking for ways to partner with institutions to enhance these tools. And so if there's a grant opportunity that would be of interest with the Midwest Cover Crops Council or any other organization, we could potentially look at developing new tools based on these freeze thresholds, implementing forecasts, all those types of things. We are certainly open to that.
Yeah, thank you. Yeah, we have a couple more minutes. If anyone wants to just even put their question in the chat, you can do that, or turn your audio on and you can ask the question. We have some time here, so we'll leave that out there. Now we need to pause for at least 10 seconds, right? And let people ask their question.
Yeah, I know. I presented a lot of information today, and it's easy to kind of get lost in that. I'm happy to also provide the presentation to Claire and their team so we can get this sent out to you all, if that's acceptable.
Sure.
Yeah.
Yeah, that would be great. And we will be sending out the recording too, and we'll put the recording of this webinar on YouTube. I'll just give us a couple minutes. I don't want to cut off any questions that are brewing.
I just want to say thank you to everyone who joined today. If you have climate data questions, more operational needs, and ideas for tools, we're an open book. So please feel free to contact our office. We're happy to respond. And we respond fairly quickly. We usually within a 24-hour period of doing so. So I appreciate everyone's time, and I'll toss it back over to Claire.